morning. Aldehydes and ketones. Okay. So can any one of you tell me what we have discussed in the last class? What we have discussed? Anyone? What we have discussed in the last class? So we have discussed about Fehling reaction or Fehling test. So for what purpose Fehling test will be done? Any one of you can tell me? What is the purpose of doing the Fehling test? Okay, haloform synthesis. Okay, yes, Krishna. We have discussed about haloform synthesis or haloform reaction. Okay. So with respect to Fehling test, first we will go with the Fehling test to detect the presence of aldehyde. Very good. So it is meant for the detection of aldehyde group containing molecules. So detect the aldehyde group. Very good. Now, what type of reagents will be used to distinguish between aldehydes and ketone except for glucose and fructose? Oh, very nice, Sanjana. Absolutely correct. So, hagadre, what is that reagent which is present in the Fehling test? So, we have two types of reagent, right? A and B. Fehling reagent A, Fehling reagent B. So, what is Fehling reagent A? So, aqueous copper sulfate. Yes. So, that is nothing but aqueous copper sulfate or cupric sulfate, because we have written CuSO4. Sulfate is -2. Okay, then reagent B, that is alkaline sodium potassium tartarate. Sodium potassium tartarate. Right? Alkaline solution of sodium potassium tartarate. Absolutely correct. Now, if someone asks you, naturally as Sanjana she has written, if someone asks what is Fehling reagent, then you can tell that it is the equal amount of aqueous copper sulfate and alkaline sodium potassium tartarate. So what is the role of sodium potassium tartarate? Anyone? What is the role of sodium potassium tartarate? Why it is there in Fehling reagent? What is the role of sodium potassium tartarate? Stability to cupric ion. Very good. In future, if you are joining to some basic course or wherever chemistry, if it is there, or higher studies, wherever there is an involvement of cupric ion, normally they will be using sodium potassium tartarate. That is because it is going to stabilize the cupric ion, not copper sulfate, cupric ion. Okay, so that's why sodium potassium tartarate. So what will happen in Fehling reagent test? What is the end result? Stabilization of cupric ion. Very good, both of you correct. So what is the end result? What will happen? Okay. So as Krishna has told, there will be formation of cuprous oxide. Very good. Right? Symbol can be Cu2O because oxide minus 2, cuprous is plus 1. Yes, it is the red brownish precipitate of, it will be red brownish precipitate of cuprous oxide. Very good. It will be reddish brown precipitate. Very good. Precipitate of cuprous oxide. That is the end result. So what it means? That means cupric ion has been changed to cuprous form. Cupric ion has changed or reduced to cuprous form. What happens to aldehyde? So cuprous oxide is getting formed means what? A cupric ion, copper sulfate. Cupric ion is getting converted into cuprous form. Now what is happening to aldehyde group? What will happen to the aldehyde group? This is nothing but reduction. Okay. So aldehyde group will get converted into carboxylate. I think Sanjana, co-oxalate you have written. I think in a hurry you have written. So when it comes to aldehyde group, that is an example for oxidation, where aldehyde group will get converted into, as the people have told, carboxylate. Very good. So this is the Fehling's reaction. This is the Fehling's reaction. Yes, there will be oxidation with respect to aldehyde and there will be reduction with respect to cupric ion. Now my question here is, in Fehling's reaction, which is acting as an oxidizing agent? Which is that one which is acting as a oxidizing agent? In Fehling's reaction, which is acting as a oxidizing agent? Yes, it will be a cupric ion. So therefore, itself it will get reduced by oxidizing the aldehyde. So naturally, aldehyde will be considered as a reducing agent. In this case, aldehyde group is acting as a reducing agent. So due to this reason, glucose, fructose, all those sugars will be considered as reducing sugars because they have the capacity to reduce cupric ion to cuprous form. And if you go back to Tollens test, silver ions to metallic silver. That is the reason why they are called as reducing sugars. That is related to Fehling's test. Now, when it comes to haloform synthesis, which type of ketones should be utilized? So, which type of ketones should be utilized? In haloform reaction, which type of ketone should be utilized? Okay. Okay, methyl group containing ketones or methyl ketones. Both correct. Very good. So, methyl ketones, compulsory. We have to use the methyl ketones. One of the group, minimum it should be methyl group. Okay. But can haloform reaction. Okay. So, what do you mean by haloform? That is nothing but chloroform agent. It will be treated with, yes, CHX3. That is haloform, general form. Okay. Now, which is that another reagent which will be used? Sodium OX. What do you mean by this? This is nothing but sodium hypohalide. So that is very important. This is nothing but sodium hypohalide. Spelling is important. In English or in science, they may not be focusing on the grammars and all, but these spellings should be proper. It should be sodium hypohalide. Yes, very good. Now, when these reagents are mixed together, that's where we are going to get the haloform. So that's where we are going to get the haloform. Okay. Now, what should be the another one product? Which will be the another product? So, another product will be sodium salt of carboxylate molecule. Okay. So, sodium salt of carboxylate, respective carboxylate, that will be another product. Okay. So, depending on the requirement, we should use the sodium hypohalite. So, what do you mean by that statement? That means if I want chloroform as the product, that is CHCl3, then I should use sodium hypochlorite. If I want iodoform, that is CHI3, I should use sodium hypoiodide. So, depending on the requirement, this reagent will change, but here it will remain constant, that is methyl ketone. One of the reagents should be methyl ketone. Okay. Now, who is going to decide the type of sodium salt of carboxylate which will be formed? Which is that reactant which is going to decide which type of sodium salt of carboxylate should be getting as the product? Who is going to decide? Which reactant? That is R from the ketone. Yes, very good. It will be decided by R or alkyl group present with the ketones. Very good. Okay. So that's where we have the haloform reaction. Now we are coming to yesterday. I think I have introduced about this reaction. That is aldol condensation. That is nothing but aldol condensation. Okay. So this is even important for your competitive exams also. Okay. Now when I am talking about aldol condensation, as I told, it is the reaction where two organic compounds will be combined together. Two organic compounds will be combined together. That's where we have the condensation. Hagadra, what do you mean by that aldol? So aldol are those compounds which will be having aldehyde and OH group within its structure. Okay, that's why it is called as aldol. Hagadra, why this aldol condensation will be shown by those compounds which are having carbonyl groups. Which are having carbonyl groups. Right? So why this aldol condensation will be shown by carbonyl groups? Because if you remember, yesterday I told aldol condensation is nothing but combination or condensation of two organic compounds containing carbonyl groups. It can be ketone or it can be aldehyde. So both are having carbonyl group. So therefore, only those compounds which are having carbonyl groups like aldehydes and ketones, only those compound condensation will be called as aldol condensation. Otherwise, condensation reaction, there are many. But when I am telling aldol condensation, I am specifying that those organic compounds should be having a carbonyl group like aldehydes and ketones. Now, the reason here is, if I take acetaldehyde, what is the another name, IUPAC name for this molecule? I can call it as acetaldehyde or acetal, but IUPAC name will be ethanol, right? IUPAC name will be ethanol. So that's where I have the molecule acetaldehyde. Yes, it will be ethanol. Yes, Sanjay. So if I observe here, this carbonyl group, this oxygen will be torturing the carbon, because this carbonyl group can be present like this or it can be present like this. That's where it will be torturing the carbon. It will be telling to this carbon that give me back my electrons. because it's an electronegative element. And due to this property, all of us we know that there will be dipolarity between carbon and oxygen in a carbonyl group. Okay? And due to this particular phenomena, alpha hydrogen, listen to me carefully, due to this particular phenomena, alpha hydrogen. So what do you mean by alpha hydrogen? Alpha hydrogens are those which are attached to alpha carbon. Alpha hydrogens are those which are attached to alpha carbon. If you go back to biomolecules, alpha amino acid, they will tell. Why alpha amino acid? Because both alpha amino group and carboxyl group. Carboxyl group it is understood. Even amino group it is attached to alpha carbon. So therefore it is called as alpha amino acid. Same logic is applicable here also. Alpha hydrogens are those which are attached to alpha carbon. So which is the alpha carbon here? Here the alpha carbon is that one which is next to the carbonyl group. Which is next to the carbonyl group. So that's where we have the alpha carbon. Okay? Now, when I am telling alpha hydrogen, it can be this hydrogen or this hydrogen or this hydrogen. Because all these three hydrogen, they are attached to alpha carbon. So therefore, all these three hydrogen can be considered as alpha hydrogens. Okay? Now, due to this particular property of carbonyl group, all these hydrogen, any one of them, they will be acting as a acid. They will be acting as a acid. What I mean to tell you is, they can be easily released as H plus. They can be easily released as H plus. Just provoke them, they will be released as H plus. Okay? But when you keep acetaldehyde as it is, don't worry. The compound is bit stable. But when you provide the condition, even a mild alkaline condition will make them to release the H plus. Any one of these hydrogen will be released as H plus. That's where the bond will be cleaved. Okay? So due to this acidic character of alpha hydrogen, therefore this aldol condensation will be happening. So why this hydrogen, alpha hydrogen can be released as H plus? That is due to the nature of the carbonyl group. Okay, nature of the carbonyl group. All of you got my point? So therefore alpha hydrogen is because of the acidic character of alpha hydrogen. Aldol condensation is majorly because of the acidic character of the alpha hydrogen. So what is alpha hydrogen? So these are the hydrogens which are attached to alpha carbon. Which are attached to alpha carbon. Same logic is applicable even with respect to ketones also. Same logic is even applicable for ketones also. Okay? Got my point? Later I will give overall picture for aldol condensation. First we will have the reaction. Fine? Now I have the acetaldehyde. Once again I will draw the acetaldehyde. Now 2 acetaldehyde will be there. 2 acetaldehyde will be there. So what I mean to tell here is, you take acetaldehyde solution and if you add dilute NaOH, or if you provide a mild alkaline condition, NaOH, OH minus should be there. Okay, so that's where better to take mild alkaline condition by providing potassium hydroxide, barium hydroxide or sodium hydroxide. Okay, so barium hydroxide is already weak alkali. Why they are called as alkali? That is because they are made up of alkali metals. Okay, same way sodium hydroxide, potassium hydroxide, they are strong. This is bit weak. So that's where they are going to release the OH minus. They are going to release the OH minus. So if I am talking about these things, we have to take dilute. That one we should mention. Don't go with NaOH. Mention it as dilute NaOH. That is very important. If you provide the strong condition or strong alkaline condition, aldol condensation will not happen. Okay, to go with dilute condition. Okay, otherwise side products will be there. That's where we have the ethanol. Now when you provide the alkaline condition, now as we have discussed, this oxygen will be pulling the electron towards it. Same thing is applicable here also, but we will be focusing on this. And due to this carbonyl group here, this hydrogen bond will be cleaved like this. And due to that, now this hydrogen can come over here. This hydrogen can come and attach to this particular oxygen. Got my point? Now what is happening? Due to the pulling of electron towards the oxygen, it will be having negative density due to electron rich. Now due to this same logic for carbonyl group, this bond will become weak. Any of these three bond will become weak. So therefore this can be released as H plus, electron deficient species. Naturally it will go here. Now what is happening? So negative, positive, positive, negative. All of you will agree? So due to that, negative part has taken positive. Now positive part should go to negative. Okay? So now due to that, what will happen? This carbon will attack that particular carbon. Therefore it is called as condensation. Enolate ion will be formed. Yes, enolate ion. Enolate means just before I had shown, right? So same logic. Carbonyl group containing compound can show the enolate form. Okay? It will form the enolate form. Now due to that, if you observe it carefully, I will write the intermediate product. Now what is happening to this oxygen? It has taken OH. Okay? And already CH is there with respect to this carbon. Now this carbon is attaching to this particular carbon, right? So what is the condition over here? Only two hydrogen, because one hydrogen is taken by the oxygen. So therefore we have got the product like this. We have got the product like this. Got my point? All of you have understood? What will happen here is, as Archit has told, there will be formation of, okay na? So that's what, and condition will be formed. Okay, dipolarity. So due to that, this will be done only with respect to carbonyl group containing molecules, especially aldehydes and ketones. Anyway, mechanism is not there for you people, don't worry, but try to understand. Otherwise, in the exam they can ask, name the product, even in competitive exams. Then you should be thorough with these things. Okay? Now what is happening? Carbon with positivity, oxygen with negativity. Okay? Now due to that, positivity will go to negativity. This positivity should go to negativity. So that's where OH, okay, and this carbon is getting attached to this carbon. That's where two acetaldehyde molecules, they are condensed with each other. Now if you observe, there is a presence of aldehyde group and there is a presence of OH group. So due to that, in general we can call them as aldol intermediate or aldol product. Okay? So quite stable only, not very unstable and all, it's not there. It's quite stable only. That's why we have the aldol intermediate. Okay? Now, what can be the name of this molecule? So what can be the name of this molecule? First we will go with IUPAC name. Okay, beta hydroxycaronyl. Okay, that is fine. So that is a common name. Beta hydroxy and all, it will come with the common name. We'll go with I place name. 3-hydroxybutanol. Okay, caronyl. Okay. So beta hydroxybutanol. Beta hydroxybutanol. Okay. Now we can also call it as 1, 2, 3, 4, right? So we can also call it as beta hydroxybutanol or 3-hydroxybutanol, or we can call it as, this is I place in a numbering, 3-hydroxybutanol. If it is having 5 carbon and all, then valerate, some different name will be there. Okay, but here we can call it as beta hydroxybutanol or 3-hydroxybutanol or butanaldehyde. Okay, better in I place name, this is the one. So 3-hydroxy